Hello, I am continuing the repair of the linear guideways of the surface grinding machine. The length of this pair of guideways is 3 meters.
If I had a suitable wide straightedge, also 3 meters long with a prismatic working surface, I would repair this guideway by simply scraping off the paint marks left by the straightedge on its surface. But since I don't have such a straightedge, I found another way to accomplish this task. I will perform the repair using the readings from an AUTOCOLLIMATOR, which allows me to work with a 1 meter wide straightedge. Since I have a 1 meter straightedge and an AUTOCOLLIMATOR, nothing stops me from starting the work. You could also perform such a repair by dismantling the machine's base and grinding it on a large surface grinding machine, but I will use a different method, repairing with the AUTOCOLLIMATOR, as I find it more convenient in this case. In the 2 previous episodes, 24 and 25, I started this repair. In video 20, I measured this guideway with an AUTOCOLLIMATOR, using a 300 mm long mirror stand, so I already had a general idea of its geometry and wear patterns, based on which the repair plan was created. These are the results of those measurements from my video 20. The measurement steps, each 300 mm long, and the results for each step. On the AUTOCOLLIMATOR scale are schematically shown in the animation. This animation helps to understand the measurement technique with the AUTOCOLLIMATOR. I want to mention that many videos related to this excellent device are published on my channel. This is the wear pattern of this guideway shown by the measurements. The guideway is conventionally divided into 3 equal 1 meter sections, as I have the technical capability to create a 1 meter stand for the AUTOCOLLIMATOR mirror and a 1 meter wide straightedge. First, I will create the prismatic, V-shaped line of the guideway. This is the most challenging part of the job. Making the second, flat line will be easier. To simplify the presentation of the material, I use the following notations. The new, restored geometry of this guideway should be in 2 ideal planes, which I called plane alpha and its opposite plane beta. Thus, a new alpha line and a new beta line will be created by removing excess material, forming the new guideway. I divided these lines into 3 parts. The boundaries of these 3 parts are the segments A1, A2, and B1, B2, B1, B2, and C1, C2, C1, C2, and D1, D2. The shapes of these segments correspond to the shapes of the support prism pads of the AUTOCOLLIMATOR mirror stand, specifically 70 mm by 40 mm. By controlling the position of the stand along with the mirror in space using the AUTOCOLLIMATOR, I can bring the segments into the correct position by scraping cast iron off the alpha and beta lines, based on the paint prints from the support prisms on these lines. I need to control the position of the stand with the mirror using the AUTOCOLLIMATOR and adjust this position by scraping cast iron off the guideway surface until the segments A1, B1, C1, and D1 coincide with plane alpha, i.e. integrate into it. Similarly, the segments A2, B2, C2, and D2 must integrate into plane beta. I prefer, and I apologize to those viewers who understood everything right away, to present the material in different ways so that everyone can clearly understand what is happening. That's why I also prepared an animation demonstrating the technique of creating the support pads, and what the guideway surface looks like after this operation. First, I made the pads B1, B2, and C1, C2. They already determined the planes of the new surface. Now, based on the AUTOCOLLIMATOR readings, the task is to create the support pads A1, A2. Then, it will be the turn of the pads D1, D2. Finally, using the 1 meter straightedge, the excess material that protrudes upward will be removed. From this point on, the support pads will serve as spatial references, and using the 1 meter straightedge, paint, and a scraper, I will create the alpha and beta lines. The 1 meter straightedge will transfer paint to the guideways until it aligns with the reference segments. But everything must be done in sequence. First, in episode 24, I created 2 pairs of support segments B1, B2, and C1, C2. In episode 25, I checked how these 2 pairs of segments relate to the vertical movement of the machine carriage, to understand in which direction to tilt the alpha and beta lines to determine their optimal positions. Accordingly, I now know that if necessary, I can lower segments B1, B2, but it is undesirable to lower segments C1, C2. Now that this information is available, I can create segments A1, A2, and D1, D2. I'll start with segments A1, A2. Here, to align with plane alpha, 0.06 mm needs to be scraped off segment A1 and 0.1 mm off segment A2 to align with plane beta. This is what I do by making paint prints from the mirror stand's wide straightedge and scraping the metal based on these prints, tracking the cross movement with the AUTOCOLLIMATOR after each scraping until the cross reflected in the AUTOCOLLIMATOR mirror centers in the scale, confirming alignment with planes alpha and beta. This is the first print. I take the scraper and cut along the paint mark. This operation is repeated dozens of times, with about 1/100th of a millimeter removed per cycle, depending on how aggressively the cast iron is scraped. The auxiliary structures around the machine base allow me to find a more or less comfortable position for directing the scraping force. If you have a quality carbide insert, and it is well sharpened, the work goes smoothly. I am currently using an excellent VK60M insert, which is rare nowadays, and there are counterfeit versions made in China, so it's important to know how to distinguish the fake from the genuine one. I check that in the basic position, the cross is in the center of the scale, then I move the stand with the mirror to the pads A1, A2. The cross approaches the center of the scale, so more work is needed. After a few more cycles, the cross is in the center of the scale. The reference segments A1, A2, B1, B2, and C1, C2 are now in the alpha and beta planes respectively. Now for the segments D1 and D2. Here, 0.08 mm needs to be removed from D1, and 0.4 mm from D2. This is what I need to do now. Here is the first print on segments D1 and D2. There's nothing to comment on, it's the same process. Make a print, scrape along the mark, make another print, scrape along the mark, check the cross position, and continue scraping. Probably most viewers consider this work boring and difficult, and perhaps it is if you do it constantly year after year. But for me, at this moment, it is very interesting, so the work goes smoothly and easily. Each paint print carries new information, and with each new print, I get closer to the goal. The interaction with the material, the tool, the measuring instrument, the scale of the task, all of this is a very interesting experience. Why is this work an exciting adventure for me, and why should it be interesting for you? Restoring high precision to the machine, giving it the ability to work again and create truly flat surfaces for which it was made, isn't that worth the effort? This is 8 tons of cast iron and steel. How many resources were once spent to make it, and I will return it to useful work by spending just a few months on its restoration. In fact, I need to remove only about 50 to 150 grams of cast iron to make this guideway absolutely linear. Thank you for supporting me through Patreon. It is very important to me right now. The link to my Patreon is in the video description. For segment D1, I have already reached the required position, and for segment D2, there is still 0.33 mm left. It's crucial to carefully install and remove the mirror stand, as even minor impacts are unacceptable. Of course, I understand that not everyone is ready to watch this monotonous work for a long time, and anyone can skip forward in the video, but I'll still show a bit of the actual cast iron scraping, as it might be of some interest to someone. Here, there's more work. Sometimes, when the spots are fairly evenly distributed, and there is still a lot of material to remove, I speed up the work by aggressively scraping an even layer. Then I even out the pad again until the paint spots are evenly distributed and scrape off another even, preferably thick layer. To remove 0.4 mm, I probably did this about 6 times. The paint prints from the ideal surfaces of the stand prisms prevent me from cutting cast iron where it isn't necessary. I only scrape the chips where it needs to be done. So, segment D1 is in plane alpha, and segment D2 is in plane beta. The cross has centered on the scale. To ensure accuracy, I check the cross position of the AUTOCOLLIMATOR in all 3 positions. The cross is centered on the AUTOCOLLIMATOR scale in each position. All the reference pads are now aligned with the alpha and beta planes. This stage of the work is complete. The reference pads are created. The AUTOCOLLIMATOR made this possible, as I wouldn't have been able to create accurate reference pads A, B, C, and D without it. I use a ground sharpening stone with a flat surface. I was curious to highlight the relief of the reference pads. The marker paint layer, applied intensely, is about 2 microns thick in this case. There were several questions in the comments about the foundation. I have no actual information about the foundation, but it is likely made according to the machine's instructions, with a depth of at least 800 mm. The machine base is anchored to the foundation and additionally filled with concrete. I assume that the foundation likely performs its function adequately. Now I need to return to the 1 meter wide straightedge. Information about it is in episode 23, as I've already started making it. Without it, I won't be able to continue the repair of this guideway, and at the same time, it will ensure the successful completion of this task. In the next episode, I will discuss aligning the working surface of the 1 meter wide straightedge. My technology for controlling the surface geometry on a special stand using a precise level will allow me to align its surface to within 1 micron along its entire length. So, until next time, goodbye.